It's easy to forget that databases weren't always able to handle all the stuff we throw at them today. Photos, videos, audio clips. They started as simple ledgers, just text and numbers. So how did we make that huge leap? Well, today we're going to dig into a really cool piece of that history. We'll look at one of the first commercial systems that really tried to crack this nut. All right, so here's our game plan. First, we'll talk about why multimedia data was such a big deal. Then, we'll introduce our star player, a system called MULTOS. After that, we'll peek under the hood at its data model and wrap things up by looking at its really smart storage solutions.
So let's get right into it. The challenge of multimedia data. What was the big problem here? Why did standard databases why did they need to evolve?
Okay, so think about it. We're not talking about simple text anymore. We're talking about this whole messy collection of stuff. Images, graphics, audio, video. Traditional databases loved neat little boxes, right? Rows and columns. But multimedia data, it's just unstructured. It doesn't fit. How in the world do you search for something inside a picture or index a specific moment in a video? These were brand new, really tough questions. All right, so with this huge challenge on the table, engineers had to get creative. They started building specialized systems just for this purpose. And that brings us to our main case study, a really interesting commercial system called MULTOS. And this was the big question they were trying to answer. Think about the office environment. A document wasn't just a piece of paper with words on it anymore. Nope, it was a complex beast. A report with pictures, a presentation with sound clips, maybe even a file with a little video embedded. The trick wasn't just storing it, but being able to file it, manage it, and most importantly, find it again, easily. And the answer, or at least one of the big answers, was MULTOS. It stands for Multimedia Filing System. And that name says it all, right? This thing was designed from the ground up for one specific job, to tame all this wild, new multimedia content, especially in an office setting. So yeah, MULTOS. Or, to give its full name, Multimedia Office Server. That name is so telling. It was designed as a client/server system, which was a really smart way to handle the filing and retrieval of what they called multimedia objects. Basically, it was built for the job. Okay, so how did it actually work? What was the secret sauce? To understand that, we've got to look at the architecture behind the system. Let's dig into the MULTOS data model. So at its heart, it's a client/server setup. It's a pretty classic model, and for good reason. Just imagine, you're sitting at your desk. That's the client. It's the part you interact with. But all the real heavy lifting, the storing, the managing, the searching, that all happens on a central server in the background. Your client just sends a request, and the server does the work. Now, this is where it gets really, really smart. MULTOS broke down a document into 3 different layers. First, you've got the logical structure. Think of this as the raw ingredients, the paragraphs, the images, the basic pieces. Then there's the layout structure. This is the recipe, how all those ingredients are arranged on the page. And finally, the real game changer, the conceptual structure. This layer is all about meaning. It helps the system understand what the document is actually about, which makes finding things way, way easier. All right, that's the what. But what about the where? I mean, where does all this data actually get stored? Well, MULTOS had a very clever 2-part answer for that. It used specialized storage solutions. See, the designers were smart. They knew that not all documents are the same. You've got your hot files, right? The stuff you're working on right now, accessing all the time. Then you've got your cold files, the finished reports you just need to keep for your records. It would be super inefficient to treat them both the same way. And this table lays it out beautifully. You had the dynamic server for those hot, frequently used documents that people were constantly updating. This stuff lived on fast magnetic storage. Then, for the cold files, the stable documents you didn't touch often, you had the archive server. This used a mix of magnetic storage and something called worm optical disks. WORM stands for Write Once, Read Many, meaning once you save something there, it can't be changed. Perfect for permanent records. And really, this quote sums up the entire philosophy behind MULTOS. Everything we've talked about, the client-server setup, that 3-layered document model, the 2 types of storage, it was all designed to do one thing: build an efficient and cost-effective system for handling multimedia documents in a real-world office. It was all about being practical. So,
This leaves us with a really interesting question to chew on, right? The core ideas from MULTOS, things like separating the what from the how it looks or using different storage for hot and cold data, these ideas are still a huge deal today. Now, as we're looking at a future with crazy complex data like VR and interactive media, you have to wonder, how can these old school principles help us build the databases of tomorrow? Something to think about for sure.